Hello Year 9, it's Mr. Stewart here. I'm making a video for you guys that is concerning aspect of slope. So this video should be able to help you understand, identify and determine what the aspect of slope is on topographic maps. You can watch this video as many times as you like until you have your head around the concept fully. What we're looking at now is a picture of Mount Aspiring, which is a mountain in New Zealand. So this mountain is particularly famous because of its distinct three-edged peak. It's quite obvious in the region. It stands 3,028 metres tall, and it's very popular to go to New Zealand and climb this mountain. Now the reason we're looking at this is because at the end of this year, this is exactly what I'm going to do. And to go over and climb mountains, you have to be able to understand the aspect of slope. Anyway, we'll have a look at Mount Aspiring later in a bit more detail. First of all, let's just quickly go over what aspect of slope is again, and then I'll give you a demonstration on how to find aspect of slope. So, wherever you are, if you want to follow the link that will be on your screen, you can bring this page up and you can work at it with. Aspect is the direction a slope is facing. The amount of sunlight an area of land receives has a big impact on its microclimate, whether it is warmer or cooler, moister or drier than surrounding areas. It is important when investigating vegetation communities or buying a block of land. In Australia, land with a northerly aspect will generally be warmer than land with a southerly aspect. Below is a photo of a valley in Kosciuszko National Park towards the end of winter. The snow has remained on the slope with the cooler aspect but melted on the slope with the warmer aspect. The line AB on the map shows the location of the photo. Slope A has a southerly aspect and B a northerly aspect. Okay, so you can see quite obviously the difference between the two aspects in this valley. It's almost a distinct line straight down through the valley, and on one side there is snow and on the other side there is not. So let's focus on the bottom map first, shall we? Normally, the topographic map you're looking at has a lot more information on it than this one, and that information is actually necessary for figuring out aspect of slope. But in this situation, we will just assume that this contour line up in this area is the highest, and this area down here is the lowest. It makes perfect sense, as this is how a natural feature would be, but normally we will want to see contour markings on these to know which is the highest area and which is the lowest area. Once we have determined the highest area from the lowest area, we find the slope that we want to look at. So let's start with slope A. The contour lines are quite close together, therefore meaning we have quite a steep rise and not just a flat valley or anything. So we definitely have a slope going on here. What we're going to do is take the highest point in our slope, which we'll say is at the top of this mountain, and we will draw an imaginary line down to the lowest point of the slope, which we'll say is down here. So I'm going to use my pen, and we have an imaginary line from the top of the slope to the bottom of the slope. Now to find the aspect of the slope, it's easy. If you draw the line from the top to the bottom, whichever direction that line is pointing is the aspect of the slope. So in this instance, the aspect of slope A is definitely a southeasterly aspect. If we check out our compass here, our 8-point compass we've got, quite obviously southeast. So let's move on to B. First of all, let's answer the quiz question and make sure we have this right. Submit. Correct. There we go. So let's move on to B. This is the higher point around here. This is the valley where all the rivers are flowing through down the bottom. We start at the highest point we can, so up about here, maybe even up there, and we draw an imaginary line through down to the lowest point. And the direction that line is pointing is southwest. So now if you want to take out our topographic maps that we were working on in class, we will have a look at some of the slopes on this. If you don't have your map, you can easily look it up online at the website that will be on your screen. So, first of all, let's find something that looks like a slope. We have all our little brown lines, our contour lines that are joining areas of equal height. And when they're close together, it indicates a steep rise. So this area over here is looking pretty good. This area here, if you can't see the cursor. So we have 4 contour lines quite close together, all parallel or roughly parallel, giving us a even face. Let's focus on this area. So this contour line, this is in the top right corner of your topographic map. At the top of what we think is the hill, it says 160, so we're at 160 meters. The next one down is 140, so obviously this part is the highest. The next one down is 120. If they were inverted, that could be 160, this one could be 180, this one could be 200, and therefore rather than a hill, we would have a big dip, a big hollow in the ground. And the slope would therefore be the opposite. So it's quite important that you have the right part of the slope as the highest part and the low part. So we have 160 in the top. Let's draw a line straight from the top to the bottom of our slope. And there we have it. And if you compare it to your compass, you will see that that is pointing in a southeasterly direction. Let me jump to there. So it was like that, southeasterly. So yeah, see why it's so important to know your north from your south, your east from your west. It helps in all kinds of geographic skills. So I hope everyone's starting to get a clear idea of what aspect of slope is. It is the direction that a slope is facing. Let's go have a look at Mount Aspiring. Remember our mountain from the start? Let's have a look at it on Google Maps, shall we? Down here in the south of New Zealand. Here is Mount Aspiring. Let's pick this face here. 2,600 meters, 2,800 meters, 3,000 meters. So up here is obviously our peak. Down here, 2,100, 2,000 meters. So we'll draw a straight line from the top down the slope. Down here like this. And we have pretty much a perfect western face. A little bit southwest, but that's the western face that we are looking at in this image here. So see what a good tool Google Maps is for geographical skills. Well, Year 9, I hope that was helpful. I hope you now have a firm grasp of what aspect of slope is. It is just another one of the skills that we need to know as geographers, and one of the skills that we need to know to be able to effectively use topographic maps. You can see how all the things that we've learned regarding topographic maps build on top of each other. So you need to have a firm grasp of each level to be able to use it effectively. Alright, so good luck. See you later.